Hi, welcome to my channel, and in this video we are going to talk about how internet works. So the first thing that I want to talk about internet, that it's a virtual thing. On the other hand, it's a physical thing as well. So why it's a virtual thing? I mean, it is pretty much understandable that what we do on internet and what we access in internet, everything is virtual. None of the things we can touch, we can smell, or physical stuffs, right? That's why it's a virtual thing. On the other hand, the infrastructure. So, like you have computers or laptops, you know, you have smartphones, or you have like ISP, routers, and many other things that are physical stuffs, right? So, infrastructure wise, it's a physical thing as well. So, that's why I said internet is a virtual thing, at the same time, it's a physical thing. Okay, now the first thing that we will learn, and it's LAN. LAN, LAN. So what does LAN stand for? LAN stands for local area network. So here you can see we have a picture. Here we have a house drawing, and house means it's a restricted area. So it could be a residence, a library, laboratory, or university campus, school campus, anything. So as you can see, this restricted area, it has 7 computers, and all these computers are connected to each other with the help of this switch device. Now switch device has come to the play, and now we need to understand what does switch device do. So this switch device, its task is only to connect all these computers to each other, so that computer 1 C1 can communicate to C6 or C7 or any other computers. So that's what is LAN, local area network. So it is always done in a restricted environment, restricted place. So that's what it is. Now the next thing that we need to discuss is how does a computer send a message or a file to another computer. So for example, here we have LAN. So in this LAN environment, computer 1, C1 computer wants to send a picture to C6 computer. So how will the process be? So let's see. Here the user of C1 computer, let's say he clicks send button. So the moment he clicks send button, the picture will be cut into pieces. So it's like you have a picture, now you want to send it to someone else. Now before that, you cut this picture into multiple pieces. Then you include each of them into an envelope. I mean, for each piece, you have an envelope, and you include it inside that envelope. And then each envelope has a header. So um, the header is like a stamp where it's written where it is from and where the destination is, and how it should be sent, how it should be received, and all the other information regarding this piece of picture. In IT's language, or in this internet language, you call it packet, not envelope. So first of all, the picture will be cut into pieces, and then each piece will be included in its own packet, and then the packet will have a header where all the required information or the necessary information will be included in that header. And then each header will go to the switch device, and then the switch device will see, okay, I mean, it will unfold the header and it will see what is the destination, and then it will determine, okay, now which computer it should send this picture to. So for example, since we have said that, I mean, since I have said that computer 1 C1 will, C1 is actually sending a picture to C6 computer. So obviously it will see that the destination is C6 computer, so it will send this picture, this piece of picture to C6 computer. That's how all the pieces will go to C6 computer, and that is the process basically, if I put it in simple terms. Now let's see what is a router. So now you can see we have a picture about router. For our convenience, I have a better view. So here you can see LAN to the internet connection. So here we learned what it is called, which is LAN, local area network. Now, how can we reach to internet? In a LAN environment, we don't have internet. Although we can actually communicate to other computers, but we cannot actually communicate to any computer that is not in this LAN environment, right? So in order to do that, we need internet access. To access internet, we need ISP, internet service provider. Maybe you have to call some ISP in your local area, then they will come to you and they will tell you that okay, you need to buy a router, and then when you provide them the router, then they will make the connection. So that's how it is done. The thing that this router will do is it will connect you to the internet. Now let's see what is the next thing that we need to know. Okay, what does the internet represent? As you can see, we have a picture here as well. So let's go to the website to see it in a bigger view. Yeah, so here we have this draw, and here it says two LANs connecting from different parts of the world through internet. Yeah, so here we have LAN 1, and in the right side it's LAN 2. For example, there is a user sitting in front of C1 computer in LAN 1 environment, and he wants to send a message to let's say C2 computer's user. When he actually clicks send button, it will go through first of all switch device, and then router, and then it will go through internet, and then eventually it will reach the destination. Now you can see internet is actually full of routers. So we have a router in our home to connect to internet, which is done by the ISP, the local ISP. Here the process happens in this way. When C1 user clicks send button, then the message, the packet, if I say it correctly, the packet goes to this switch device, and then this switch device actually unfolds the header and it sees the destination. When it sees the destination is not any computer in this LAN environment, instead it says the destination of this packet is actually outside the LAN, and it should be gone through internet. Then it sends this packet to the router, which actually connects us to the internet. So then this packet will go to the router. So when it reaches router unfolds the header, and then it says the destination. Then it determines we need to send it to the internet. So when it sends to the ISP, the first router it receives, that router again it checks the header, and then it sees the destination and the other information, and then the process is something like it has an algorithm inside that router, and actually every router has an algorithm. So with the help of this algorithm, it determines which path is the correct one to send this message. It doesn't work like each router, when it gets the packet, it just sends the packet to the nearby router. It doesn't work like that. So it sees efficiency and convenience because some router may be busy, some router can be not clear enough to send the message to the right direction. So that's why it uses its algorithm and then it sends to the correct router, and that's how it reaches to the destination. By the way, here is another thing that we need to understand and we need to know actually, and it's when we are in home, we use home router, right? So in home routers, it has switch device feature, it has the router feature, and it also has wireless feature, which is access point device feature. By the way, I think I didn't mention about access point device when we were talking about LAN. So in a LAN environment, we obviously need a switch device to make the connection between these computers, but we can actually do this thing wirelessly. I mean, you don't like cables or wires, so you want some wireless system. So in that case, we cannot use switch device. Instead, we need to use access point device. That's what I didn't mention earlier. So what I was saying is, in home routers, we have all these features in one device: switch device, access point feature, then router feature. That's that's all we can say about this. So here you can see we have a picture of a world map. I mean, it's a world map picture. That's what I'm trying to say. So here you can see all these cables are actually connecting us to one continent to another continent. So these are called submarine cables. So these are underwater submarine cables, and there are 468 cables under the water, and these cables are the most important thing of internet today. What the most important thing is, these cables are actually fiber optic cable. That's why it's lightning fast. You can understand that now I'm in Bangladesh, and if I send a message to someone in USA, it will be gone so quickly, like 1 or 2 seconds. It will take only 1 or 2 seconds, or it could be like 3 to 5 seconds. Now we need to see connecting to the internet from a computer's perspective. So we can open the website to have a better look, a better view of this draw. So here you can see we have a home environment where we have a device and it is connected to a home router, and this home router is connected to internet, and we have Udemy website as an example. So for this metaphor, let's say this user wants to consume a content of Udemy website. So this computer or this user will send its request to the Udemy website. So this uh, request will go through this router and then internet and then Udemy. And when Udemy receives the request, it sees which user is actually sending this request to us. Actually, Udemy doesn't just see the request and provides the content. The first thing it does is it verifies the user. When it sees that okay, this user is a valid Udemy user, it looks into the header and it says what is the request. The header is the verification key of this user and the other stuffs, right? I mean, it unfolds the message, and when it sees that this user wants to have certain content, then it sends the content, which is usually a video. So it doesn't just send this video to the user directly, the whole of it at once. So what it does is it cuts down the video into pieces, and it sends a whole video piece by piece to the user. So that's how the video, the content comes to the user, and this process is called streaming. Coming to the user piece by piece, packet by packet, this process is called streaming. And another thing that we need to understand is Udemy has a very large library of contents. I mean, a huge amount of storage it has. So it requires some powerful servers, and Udemy has distributed servers around the world. So when you make a request to Udemy, it doesn't go to singular place. The request goes to the suitable server where it can actually get the content to the customer within a very short time efficiently. Now there is a question arises, and the question is, does that mean each server contains the same content? Actually, it doesn't work like that. Now in my notes, what I wrote storing every single video on every single server would be incredibly inefficient and expensive. Instead, streaming platforms use a content delivery network or CDN to manage where videos live. Here is how it actually works. So here actually you can see what is written here, the origin server. So there is an origin server of Udemy, and there it has all the contents stored very much carefully, and there are CDNs around the world, and Udemy uses these CDNs to deliver the contents efficiently. So the contents that are very much popular in your area, they get cached. So let's say someone made a request to the Udemy to get some content, then he doesn't need to get the content from the central location. Instead of that, the video will come from the nearby CDN server, because the content is very much popular, so it must be cached there. That's how the caching system works. And then it also has demand based storage. I think it's the same thing, although I have written it separately. So here it says that if many people in a specific region watch the same video, it stays cached on your local edge server for fast access. That's what I already said. If a video is rarely watched, that means, let's say a video you are requesting for, but the video is not very much popular, then what will happen? Then it will not come from the nearby CDN server. Instead of that, it will come from the primary source, the origin server, right? So it will come from the origin server, and that's why it will take some time. If it was stored in the nearby CDN server, it would have taken a very less time. So that's why CDN servers are very much useful, and that's how all this system works. So in short, we can say they store the content strategically based on popularity and location, rather than duplicating everything in everywhere. Alright, now let's understand what is wide area network or WAN. So previously we understood what is a LAN. So LAN was actually local area network, and WAN is, if I simply put the definition, then WAN is basically connecting multiple LANs in a single network. So let's say a company has 2 or 3 different offices in 3 different locations around the world, and they want to be connected in a single network. So in order to do that, we have to make a network connecting these LANs, and that will be a WAN network. The whole internet is itself a network, and it provides the connection between 2 LANs located in 2 different parts of the world. Then why is a special kind of network like WAN even needed? So you have to understand that internet is a public place, and there are people who want to take advantages, right? So it can be insecure. I mean, the packet you send from LAN 1 to LAN 2, it can be seen and manipulated by other people. So that's why WAN comes into the play, and it gives you the solution regarding security. Now, the important thing you need to understand is, in general, setting up a WAN is costly and not an easy task. But through VPN, a WAN network can be created, and it has the tunneling feature, which provides privacy, anonymity, and security on the internet. So I can give you a better view if I go to the Excalibur website, and here you can see LAN 1 and LAN 2 are connected through tunneling feature, and it goes through internet, right? Now you have to understand that this tunneling feature doesn't represent a physical tunnel. Actually, it represents a highly secure system, and there you can actually have a communication between two LANs, and that's what it is. Basically, it's a highly secure system. That's what it is. Now let's understand how this tunneling feature actually works, right? So when you send an information from LAN 1 to LAN 2, first of all it goes to the router. By the way, if you have a VPN software, then before it goes to the internet, before it enters to the internet, the first thing it does is encryption. So it encrypts the information, it converts the information to something like random scrambled text. So when it goes to the internet, the ISP or the people who want to take advantages, they cannot understand the information and they cannot trace the destination, because it doesn't just directly go to the LAN to the destination. First of all, it goes to the VPN server, where the VPN server actually unfolds the header and they see the destination, and then they send the information to its destination. But in that time, it gets decrypted and the information safely reach the destination. So that's how the tunneling feature actually works. Now let's go to the next topic, which is router in a WAN network. So you can see this picture. Now I can go to the Excalibur website to get a better view. So here you can see Office 1 and Office 2, they are connected through ISP WAN network. So previously I said that WAN network, building a WAN network infrastructure, it's not very much easy and it's costly. So if you have the money, if you want to spend the money, then you can build such a network. So you have to contact to the ISP, and then you can tell them to create such an infrastructure. How is this connection made, right? So the connection is made by this router. We have known that this router, its task to make a connection between you and the internet, right? So it's a internet related thing. That's what we all knew. But here you can see it's not just an internet related thing, rather it's a thing that connects two LANs. So basically the real job a router does is it builds connection. Now the next thing we need to understand is ISP, how the ISPs are designed, right? All the ISPs are connecting to neighborhood houses, and all these local ISPs are connected to regional ISPs, and then all these regional ISPs are connected to global ISP. Now here's the thing, and regional ISP maintains a connection between a central ISP, the regional ISP, and all the local ISPs in a city, in a town. And then there are so many other cities, and all these cities have their regional ISPs, and they are connected to the global, one single global ISP. Let's say this country has a global ISP, and all the cities have their own regional ISP, and the country's global ISP are connected among other countries those countries also have global ISPs, and there are some local ISPs that are connected, they can be connected to global ISPs, right? This is rare, but this can happen. And you can see that here our local ISP 4 and local ISP5 they are connected to global ISPs. Alright, so that's how internet is designed, and I think that's enough for you to understand how internet actually works.